readings that we're supposed to go through this week, there are some important facts that Robert Glass gives that are related to this. A couple important things. First, and I've mentioned this, SQA is often, oh, well, that's testing, isn't it? No. No, quality assurance is a continual process for every single delivery that you have. Now, a lot of your deliveries, I mean, how do you test an org chart? Well, part of how you test an org chart is you pass it around and see if everyone actually understands it and agrees with it. People say, well, no, that's not my title, or why am I reporting to her? The point is that you have to have that focus on quality, make sure you're doing the right thing, because there is enough, to get all the way back to no silver bullet, there is enough essential complexity, essential difficulty in trying to simply bring a software project of non-trivial complexity to completion, that you've got to really stay on top of it. And this is from a white paper I wrote for Fannie Mae back in '96, that everyone, and actually Chuck Knudsen and I have had some debates and disagreements on this, because he was heavily involved in quality assurance at Novell after he got his bachelor's degree, and I think before he went back and got his PhD. There are arguments to be made whether you want to have a separate QA department or whether it should really be integrated completely with the development team. That's less important than the fact, and Chuck will argue very strongly it needs to be integrated. You shouldn't have a separate QA department. My standard argument is that's a nice ideal, but most places I see they really need a separate QA department because developers just won't do QA. But the problem is that developers need to do QA. Everyone needs to be involved in quality assurance. Core quality values. And this is taken, one of the things I added to the reading list for this week is a white paper I did while at PricewaterhouseCoopers. I reviewed documents related to about 120 software development projects that ended up in litigation. And found that most of them fell into one or two of 6 patterns. But in analyzing this and looking where the areas of dispute were, these are the core quality values. These are the things that are of value to whoever's paying for the software, either in terms of a business or investor, sponsor, who's underwriting a corporate in-house project, or your customer. Reliability. It's got to be correct. You want it to run. You don't want bad data. You don't want bad answers. All software above a certain complexity will have errors in it. And next week we'll talk about the relative importance of errors. But the point here is what's unacceptable. Performance. It has to complete its operations in sufficient time. I've mentioned with pages, one of our key issues was the delay between when a person presses down a key and the letter appears. And any lag, if I'm a pretty fast typist, not great, but pretty fast. Back in high school, I was about 55 words a minute. I haven't measured myself for years. But if you've ever used an editor where there's a lag between when you type and when the letters appear, it's maddening. And you will abandon the editor pretty quickly out of frustration. Functionality, it has to have, and a lot of you have been addressing this with your minimal viable product. What is the minimum amount of functionality for this to be accepted, and then what is the functionality that will give it a competitive edge? Compatibility with existing IT systems and or existing document formats. Does it read in XML? Can it read in a Microsoft Word document? Can it, talk TCP/IP, get out over the internet? Lifespan. How long is this good for? Is it going to be obsolete far too soon? Is it tied to something that's very ephemeral? Something that's going to go away quickly. Deployment. Can this actually be deployed on the target systems? Will it run properly within the constraints of those target systems? Support, and we will talk about maintenance. Does it have the capability of being fixed and extended over time? And cost, can you afford it? A lot of projects get killed because they reach a point at which whoever's funding it has said, look, we've already put $50 million into this. We don't see a viable system that's going to get us any return on investment. We're not going to throw bad money after good. We're going to pull the plug now. So these are all considerations. Now for your projects, you're probably considering only a very small subset of these, but these are things, if you have intent on developing software, are all questions you have to answer. That's where I'm keeping. Okay, this is a diagram I came up with at Fannie Mae when I was asked. You may remember, Fannie Mae was, I was a consultant there in 96 to 98. They had this big object technology initiative. OSG was in there. We had about 20, 25 consultants. I was the lead consultant there. And some of the managers thought, oh, we're switching to object technology. We don't need to do QA. It will all just work. No, seriously. Seriously, they said that. And you know, after I picked my job off the floor, I said, no, it's tougher. One of the advantages of object technology is that you can bundle up and hide a lot more complexity, but more complexity means more things that can go wrong. And beyond that, it's not just some college students banging on keyboards for a few weeks. So I came up with this whole iterative process here. And I'm simply going to show, we may talk about this more at length next week. But the idea here is this deliverable, this process activity, this deliverable is any deliverable you produce. You've already been producing your org chart, your schedules, your requirements, your design, you're going to do your test plans. And what you have is this iterative process. You have anything we have expertise. You want people who know what they're doing. Who have, remember Tempest, talent, education, professionalism, experience, skills. Who have the right things to bring to bear. Some of you I know are using game engines, and you've got people on your team who know how to use those game engines. So you've got the right expertise. If you're going to adopt a game engine and no one on your development team has ever used that game engine before, you're going to have a long, slow climb to competency to be able to use it. Guidelines and standards. This is from your methodology. It can be coding guidelines. It can be guidelines in your database architecture. Here we're going to go, third level normalization. Eventually, with ability to denormalize for performance purposes and so on. You have existing deliverables. These can be templates. This can be the work that's under process. So if I produce, and this is what you guys are already doing. I do my activity to come up with my schedule. I come up with PERT and Gantt charts. I do some form of review, ending an evaluation. And then I go back, it gets checked into configuration management, which is your time machine thing, and that's what I do for my next iteration. The idea here, let's see, I think I talked about all this on this slide. There we go. The idea of this process, and then like I said, we'll get into more detail on this next week. The class chapter that you have for next week is all on quality. But the idea here is that you need all these pieces working together in order to successfully deliver a project. And if there's anything here that you're leaving out, that's where the failure is going to occur. That's where stuff is going to erode. How many of you have seen the photographs of the main spillway at the Irwinville Dam up in Northern California? basically they had a problem, they're not quite sure what it is, but something undercut it, and the concrete about 2/3 of the way down the spillway started to crack a little, and they're having to release lots of water because they got so much rain that the lake was literally lake overflowed. And the constant pressure of water has just blown this enormous crater into the spillway. It's probably going to cost at least $100 million to repair. Once enough water, once they get to a dry enough season, that they can actually shut things down and repair it. They can't do that right now. The same thing is true. The areas where you neglect stuff is where, under the pressure of the development process, things will start to erode and blow up. We won't get into types of software testing right now, other than basically you have testings at each level of complexity: individual units or classes, groups of related classes, integration testing of your different components of your system, trying it out within a production environment or on your target environment, be it Android or iOS environment. Performance stress testing. I see a lot of failed projects that get the performance stress testing. In other words, it's got the functionality and the reliability, and then they try to use it in a real life production process, and it's running as tenth as fast as it needs to be used in a real world situation. It's kind of like, well, we tested it with one user, but it's going to be deployed to 1,000 simultaneous users. If you haven't been doing the stress testing, you're in trouble. User acceptance, usability testing. A lot of projects founder on that. This is back to the classic thing I keep saying, we want it to work just like the old system, but better. There's a whole change management issue, not configuration management, but business process change management. And regression testing. You should have an automated, for regular projects, you should have an automated regression test suite, so every time a change is checked in to the system, you can run a regression test suite and say, okay, it didn't break anything new. You'll see various figures bandied about, but typically the ones you see the most are you have between a 15 and a 25% chance of a bug fix introducing a new bug or reopening an old one. And this is often because instead of going through all the tests up to regression test, the developer says, oh, I know what the problem is. It's this line of code. I'll change it. I checked it in. It's fine. And of course, that has side effects that the developer didn't see. So with that said, building your test plan. Your test plan, which is due Saturday night, should tie back to your requirements design. Those of you who have identified requirements with unique codes, you give some level of traceability there. You should be interested in the very least with reliability, performance, and functionality. Does it work correctly? Does it work fast enough? And does it have the minimum set of functions necessary? Your test plan should indicate what tests are being done and when they are finished. In other words, what is the success condition of the tests? And you should have some form of user acceptance testing, saying, we grabbed someone off the street, gave him the dungeon, or he's doing the dungeon RGB. You grabbed someone off the street and said, here, try this. And the guy said, oh, that's cool, or I have no clue what I'm supposed to do now. In Meyer and Rechten, if this were a 2-semester class, you'd all have to buy and read The Art of Systems Architecting by Meyer and Rechten. If for nothing else, for Appendix A, which has maxims on systems architecture, one of the maxims says, I hate it, is useful feedback. In fact, sometimes that's the most useful feedback, is to have someone simply say, I hate this, I don't like this at all. Because it means that you have made assumptions that are not there. Joseph went back and found a sample test plan. It's already out there. If we go back to, if you go to the There we go. Here's a good example right here under announcements. And here's a test plan